amusement. All right, chi-squared model. Chi-squared models allow us to test a hypothesis about categorical variables. Notice categorical variables for this. We never construct confidence intervals with the chi-squared statistic. Also, different than what we've been doing. Chi-squared model is skewed right. They are parameterized by their degrees of freedom and become less skewed with increasing degrees of freedom. So basically, draw a picture. 0, 5, 10, 15, 20. So the blue one is degrees of freedom 9. Looks like a what?
What it's called? Normal model?
A pretzel?
I was gonna say heart monitor.
It looks like an EKG. If your EKG.
If your EKG looks like this, you're probably dead. Or on your way out.
Yeah, on your way out the door.
Because I pulled the plug on.
Josh would be the
Josh,
person
would
to
you
pull,
really
to
do
pull
that?
the
Josh,
plug
would
so
you
you can
really
charge
do
your
that to
phone.
me? Would you really do that to me, Josh?
Depends on how nice you are.
What? Don't pull the plug on me.
I don't think Josh is gonna be the one in charge pulling the plug on you. Just saying.
I'm just gonna come in during the middle of the night and
Pull the plug.
What?
R.I.P.
let's say mode mean.
Mode?
Mode and then mean.
Oh, okay.
So everyone can see. Does anybody remember the relationship of
Oh, just let her finish.
mean and mode if it is skewed right?
Oh,
Oh
yes.
my gosh.
Skewed. If it's skewed, use mean. If it's uniform,
So if it's skewed right, the mean is bigger,
Yes.
Yeah.
as you can see up there.
Correct. The mean is greater than the mode
bro, who is
because it is skewed
This is fun.
right.
Oh,
Bye.
The mode is at chi-squared is equal to degrees of freedom minus 2. The expected value or the mean of a chi-squared model is its number of degrees of freedom.
heard that man?
18, dude.
yeah.
I'm unsure what just happened. The chi-squared statistic can be used to test whether the observed counts in a frequency distribution or contingency table match the counts we would expect according to some model. The chi-squared statistic is calculated as, and just so you can remember, this is the sum of, and then the formula that I was saying earlier is expected cell count is equal to the row total times the column total divided by the total. In each cell of a two-way table, a standard residual is observed minus expected over the square root of expected. When we reject a chi-squared test, an examination of the standardized residuals can sometimes reveal more about how the data deviated from the null model. Degrees of freedom for chi-squared test depend on the dimensions of the table and not the sample size. This means that increasing the sample size increases the ability of the chi-squared procedures to reject the null hypothesis. So something to note about here is that the degrees of freedom is equal to rows minus 1 times columns minus 1 for homogeneity and independence.
She done teaching.
Okay. Your test is right there. All right. So the different types of the chi-square test, obviously we mentioned them earlier, but a goodness of fit test is not a two-way table. The test of homogeneity is a two-way table. Things that you're looking for this are same, equal, no difference, the test for independence is also a two-way table. Things you're looking for here is association, related, and then when in doubt, just say chi-squared test because all have the same procedure.
What were the last couple words?
Huh?
What were the last couple words?
All have the same procedure? Did you get because?
Yeah.
All right, so this first one, medical researchers enlist 90 subjects for an experiment comparing treatments for depression. The subjects were randomly divided into 3 groups and given pills to take probably over a period of 3 months. Unknown to them, one group received a placebo. The second group, the natural remedy, St. John's wort, and the third group, the prescription drug Posterex. After 6 months, psychologists and physicians who did not know which treatment each person received evaluated the subjects to see if their depression had returned. Any guess as to which situation we're dealing with here? Which of our 3? And we may or may not do them in order. So don't just say the first one. Unless you really think that's what it is.
Test of independence. Goodness of fit test. Yeah.
I don't know, maybe we're going for the homogeneity because we're trying to see if they all work the same.
I think I would say golf test.
So I have 2 Goffs, 1 homogeneity. Peyton, what do you think?
I'm gonna say that.
Okay, it is homogeneity.
I don't see any other words.
I don't even know what's homogeneity.
Yeah, I was supposed to say that.
So the one thing, where was it that I saw when I was reading it? Well, I was thinking when it said comparing treatments, but that wasn't one of the words that they gave us, but that's kind of why, because we're like comparing the different thingies, basically. It's another one of the key things, but all right, so what is in the table is the observed values. We don't have any of the totals, so how many like things are in each?
30. 30.
That's nice.
And then how about this one? This total.
Oh,
60.
30.
What?
Just 30.
Oh, that's a 6 on me.
And then the total is y'all heard that too, right?
Yeah. Yes, sure.
Wait, so could you repeat why we're using tests for homogeneity?
Because it's comparing the treatments.
So should we add that to our little list of words for the
You
report?
can, yeah. Yeah, I didn't realize that one wasn't on there, so that's why that's the word that stuck out to me when we were going through it, and then I was like, oh, we didn't write that one down.
I didn't really notice.
Obviously, we haven't written down them all, but it'll just kind of. But it's like it said, the process is the same regardless, so it's just,
It's just like actually.
except for these are two-way tables, whereas golf is not a two-way table. Let's find the expected values really fast for each thing. So you'll do 60 times 30 divided by 90 for this expected value.
Okay.
So somebody take that one. Josh has that one. Josh 1 has that one. 30 times 30 is going to be this one. Somebody else get this one. For this one here, well, these ones are going to end up being the same because these are 60.
They all divide by 90, right?
Yeah, all divided by 90. These actually are going to be the same going across the top and across the bottom because the numbers are the same, 60 and 30 for everything. So what is, I'm going to just do expected here in red because we're not going to have time to do this whole problem. So what is the expected value for this one? 20. So these are all 20. And how about the bottom one? 10. So those are going to be our expected values there. Any guess about what our null hypothesis is going to be?
They're all equal.
What is?
The
The
effects of the treatment.
Yes, basically. The recurrence of depression is the same for all 3 treatments. The alternate would be that the recurrence of depression differs for the treatments. So we'll go over the assumptions tomorrow and then finish up this problem. To do a throwback to matrices, because to put this stuff in your calculator, you have to put them into a matrix. I'd forgotten about that little piece of information.
How do you multiply matrices? I forgot.
with our calculator.
Yeah.
How do you do it by hand?
First row times first column plus, like, this one times this one, plus this one times this one, plus this one times this one.
I don't know, I think you just like, so many times didn't start trying.